This is basically what this chapter or this section is saying, you know, all those pages and pages of junk that I've made you do, you don't have to do it no more. Till Monday on your test, you have to do it, okay? It doesn't go away. Unfortunately, in this class, your final's comprehensive, so you'll have to do it again for the final. But this is just shortcuts. That's all this section is how to do shortcuts on things you've been doing for pages and pages. So if I have a constant function, okay, meaning if I graph it, the slope equals what? So if I have a constant and I take the derivative of it, because the derivative is the slope, then so that's all this is saying. So if I want to find the derivative of 3, what's that equal? If I want to find the derivative of pi, what's that equal?
0.
If I want to find the derivative of
0.
That's a constant. Yeah, okay. All right, so again, though, not just memorizing, you know, numbers here, understanding that this is a function, which is y equals 3, meaning it's a horizontal line, and that's the reason why, is because the slope is 0. All right, that will be forever on YouTube.
Well, you said like they sold that as there are no allows to take some things. So
What is this? What is this row here all texting? If you are a Cowboy fan, move over and you are exempt from your test Monday.
They're automatically.
All right, so what we did last time, and this is good practice for your test. However, I did tell you, I think I told you, I did not put a cubic on there, so you know you don't need this formula. But this is doing what you've been doing the hard way, meaning we do our f of x plus h minus f of x. Where I see an x here, I plug in my x plus h, I plug in my x, I do all that crazy algebra stuff I do, where things cancel, and then I get this answer. Now, for those of you that have not had this in high school, you might be able to look at that and kind of see the little trick, and that's what we're going to power rule. The power rule simply says, well, all I have to do is take whatever this exponent is and bring it down front, and then subtract 1 from my exponent. So if I take crazy all these steps, I can say, well, if I have f of x equals x cubed, my derivative then is bring the 3 down and subtract 1. And so you say, then why did I have to do all that crap? Because I had to do it and I had to suffer, so you have to as well. I don't know. You know, and it makes you wonder, you know, the dude that came up with this must have been lame. Like, lame! And then this is our hero. All right, so on your test Monday, let's just say, for example, this is a question, and let's say it's worth 20 points. If you don't do all this and you just do this, we argued in my other class, I would give you a whole point for that. That's kind of nice of me, I think. Or maybe we'll do a point spread of the Cowboy game.
That's going to be a lot of points.
All right, so my point is, even though you can't use these shortcuts for Monday's test, you can at least check your answer. Okay, so, and some of you that had this in high school have already known this, that when you get through all these steps, you can say, well, that makes sense, because if I do the shortcut way, I do get that answer. You'll be able to use it on Friday's quiz. All right, so here's this big old bad one I asked you guys last time. I guess this is just used a lot. Who remembered that? We went through all those steps. And so now we say, well, we don't want to go. Come on with it. So if I have this, f of x equals square root of x, I can write that as x to the 1/2 power, and now it, now it looks like a power. So I have my power rule, meaning for my derivative, I bring the 1/2 down, and then I subtract 1 from the exponent, and so I end up with x to the minus 1/2. And then remember, I can bring that to the bottom by making it positive, and of course the 1/2 power is the same thing as that. I know I did that probably in way more steps than most of you would do this, But this is still a shorter way, a shortcut way to be able to find this derivative. So anytime you see things with, for now, we'll do something here in a little bit later with chain rule, but now that anytime you see something with a radical, not just square roots, always change it to an exponent. Yes, sir?
When we simplify for our final answer, do you want us to solve through to where we don't have the square root function or square root on the bottom?
For me, it doesn't matter. And probably even since this tends to be your definition, I would think my math lab wouldn't care either. Yeah, so that's fine to do that.
1/2x, not
No, that's fine too. Yeah, yeah. All right, so now the constant multiple rule, this is if I had something like I wanted to take the derivative of, I don't know, 3x squared. What all this is saying is I can bring that 3 out front and then just take the derivative of x squared, which the derivative of x squared is what? 2x. So those of you, again, that are just learning this, they brought the 2 down and then subtracted 1, and then you get your answer. Now, when you get good at this, most of you already that know this from high school are probably like me. You don't go through all those steps. You just bring the 2 down here and multiply it. 3 times 2 is 6, and then you subtract 1, and you get the same thing. But it's nice, the whole thing of pulling those constants out front, because if you have something very messy in here, you can deal with that later and just say, well, let's pull, especially if you have negative signs, if that's some other function, you know, something that you're going to end up with a constant value, okay? But again, getting these where you can just look at them, and I realize, you know, there's, I don't know, probably half and half of you have had this in high school. Those of you that haven't, it takes a minute to think about these, but I think once you get this down here, that, oh, I just bring whatever that power is, I bring it down, and then don't forget to subtract 1 up there. For some reason, this bothers students, so let's see if it bothers you. What's that derivative? Why is it -1? Yeah. So if you go back to what you're doing, and I think sometimes you lose track of that because we're doing all this junk and I don't even know what this means. Remember what we're doing, we're finding slopes. Well, that y equals mx plus b, isn't my slope -1? So I can just look at that. And I want you to be more that way with something like this. If you have a linear equation, whatever number is out here is going to be your answer. However, you could do this the way we just learned, which said, let's put a 1 right there, bring that 1 down and subtract 1, and anything to the 0 power is 1. So -1 times 1 gives me -1. So it works either way, but knowing this way of the slope makes it nicer because when you have something like that, now what's the derivative? You want a negative on yours? And that is why he's a Houston Texan fan. All right, so in other words, all you do is just look at that because that's the slope, because this is my function, y equals 3x, a linear function. All right, so again, the sum rule, there will be times that you like to pull these functions apart, but you know, once again, most of you probably are okay with just looking at them. So if I have something like I want to find the derivative of x to the 4th plus 12x, what this rule says is I can split those apart. So I can do that derivative, and then I can do this derivative. And what's the derivative of x to the 4th? And what's the derivative of 12x? 12, okay? So again, and don't let me go too fast for those of you that are just learning this. They're bringing that 4 down. That's where that 4 came from, and then subtracting 1. Okay, so that's where the 3 came from. And then, of course, here we just talked about that's a linear, or you could say you're bringing the 1 down and subtracting 1 and getting the 12. How's about, and this is where I said some of you can just go one step. What if I have this, 4/3 x squared minus 5x plus 1. Let's just do it straight without separating it. What's the derivative of x cubed? What's the derivative of 4/3 x squared? There you go. And the derivative of 5. And that, of course, is a constant, so 0. Okay? So again, here, bringing the 3 down, subtracting 1. Bringing the 2 down, okay, so 2 times 4/3, got the 8/3. And then, of course, there's my linear once again. So you don't have to sit and separate these, but you might get to the point where, well, what if that's a trig function, that's a log function, and you only want to deal with one at a time. All right, again, I really hope that you remember what you're doing here, because we get so caught up with all the algebra, is when we went through and just did this one and found the derivative as 4x cubed plus 12. Okay, this is my derivative. And so now, if I said, well, what I want to do is look at x equals 1 for my function, this is my original function, then I could find the slope at x equals 1. How? Plug it into the derivative, because once again, the derivative is the slope. Or if I say, how is this function changing at, say this is a time, at 1 o'clock, then you would just simply plug that in. So that means my slope is 1 cubed, and that's my slope. I give you x, I have a slope, can't you get y? How can you get y? Plug it back into your original function, so 1 to the 4th plus 12 times 1. And now that you have all this stuff, you can do this whole tangent line, which is, again, good practice for your test Monday, is I would just start plugging things in. I have a 13, I have a slope, and I have an x value. Okay, I'm going pretty fast, so slow me down if there's something that you're missing here. And then once again, as I said, I'm happy with that, but if you want to graph it in your calculator, and this would be my whole point, is I would graph that, and I would graph my x and y value, my point, and what better happen is at that point, that line better just go through it, only at that one point. So, and it does. Okay, so it just makes it not, one, I keep saying this is a way to check your work, check your work, check your work. I'm just saying that to make you try to buy that. What I really want you to do, why I want you to do this, is to understand what you're doing. Okay, because again, you get so caught up with this, you've just memorized all these rules to find derivatives, and you forget what you're doing. You're finding at that value right there, how fast is this function moving? And then if you want to use the tangent line, and you might say, well, why do you even need the tangent line? Well, in this case, we're just using it to check. You could use this as an approximation. This is saying how fast it's moving here, so if I want to go a little bit over, I could also use this, and that's what they normally call this, as a tangent approximation line. All right, finding a horizontal tangent. A horizontal tangent would look like that, pretending I actually hit that, which means the slope equals what? 0. So if you're asked to find something like this, then that means you take the derivative, you set it equal to 0, and then you solve for x. So if I have something like y equals x to the 4th minus 2x squared plus 2, what's the derivative? Minus 4x. Okay, so again, just bringing the 4 down, subtracting 1, bringing the 2 down, subtracting 1. And now I set this equal to 0, and I solve this for x. So probably the best thing to do is to factor out a 4x. That's my difference of squares. And then if you remember, you set all these equal to 0 and you solve for x. So that means I'm going to have 0, -1, and 1. So that means that this graph has horizontal tangents at all of these x values. And of course you could get the point by plugging these values in here and get the actual point. This is going to become very useful, and you could probably tell by looking at this, and we could even do this way, when we're interested in finding minimum and maxes. I mean, it makes sense. If I want to know what the max is, well, where is it, the slope becoming 0? So, I mean, we'll have a whole section. You'll see this again, that we want to find the maximum of a function. All you do is you take the derivative and set it equal to 0. And so there's the picture of the graph, and as you can see, there's my -1, 1, and 0. So again, you know, pays to graph the function and see, did that make sense with your actual answers? All right, those of you that had this in high school, what do you remember the derivative of e to the x is? Yeah, everybody loves that one because it's the same thing. If this is not a proof, what this is let's kind of see if we can figure out why, and then we'll do a formal proof. The reason this is not a proof, when you prove something, you don't use numbers, okay? We say for all x. Well, I'm going to say, well, let's just try and find, remember this is the derivative, the f prime, and once I find the derivative, I plug in a 1. So the first thing I do is, and this is going back to chapter 2, is I say, well, I know I have this definition. I'm going to plug in, this is my x value for various values of h. In a perfect world, your h goes to 0. Well, we can't let our h go to 0 because we'll divide by 0, so let's let it get close. Okay, so I just tried. Now I take my actual function and plug in these values. So that's all I've done here is plug those in, and I get a number. And your boss comes back and says, well, 1/10 is too much error. I need that error. I'll make a smaller error. We have measurements so we can make this smaller. I do the same thing. All I'm doing here is changing my h, and I get this value. Smaller, and I get this value. And what is that number? E. Okay, with certainly more depth. We'll see. All you're noticing here that I'm changing is my h values. I'm letting h go to 0, basically. I'm letting h get smaller and smaller and smaller and smaller. And of course, because this is just like pi is a number with many, an infinite number of decimal places, the same thing with e, it's just a number. Interesting is where this actually came about, and you know, probably most of you have not taken many business courses. I had to teach a business math once, so that's how I found out about this, is this actually showed up way in the olden days from banking. That's where it came from. And why it showed up in banking is when you get a credit card, what do you think happens to the interest? It rises exponentially. And so that's what they figured out, is this number just kept showing up in the compound interest formula. And that's how actually the number originally originated. And then, of course, you probably remember that it's used for natural logarithms, base e. Kind of see what's going on, but now let's look at a formal proof, meaning for x. I don't want to do it for x equals 1. I want to leave x alone, and I want it for any h because I'm going to let that h go to 0. So I do this first step again. I plug everything in. You're probably used to going from this way to this way, but I worked backwards. If you have these same bases, okay, these are the same bases, and you're multiplying, then you add the exponents. So what I did is I split them up. And the reason why is I'm going to be able to factor x. This e to the x is a constant, okay? Meaning that, well, for what x value? You give me an x value, you're going to end up with a number. This could care less about what h is. It's got nothing to do with it. In fact, you probably should just pull it out front here. The only thing I care about is this piece because that's where my problem happens with my h being 0. So what I do then is I say, well, once again, looking at error, I can't just plug in a 0 and I have no idea, well, what can I do to find that limit? So I could pick values very, 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 very close to 0 from the left and from the right because they have to approach the same value. And I look to see if that's happening. And of course, as you can see, 1, meaning this piece right here, that's all I'm looking at. If I take the limit of that as h goes to 0, this is approaching this limiting value of 1. And thus, this again came out front. I plug in a 1 for that limit, and this proves that the derivative of e to the x is just e to the x. Now, we have these little, I call them cheat sheets, the formula sheets. I will try to get one, I should have it Friday for you, but just in case, have these on the side. The reason I would like to give you mine is because what we can do is we can go and check the ones off we've done, because a lot of times when you get formula sheets, those formula sheets are going to have Cal2 formulas on them too. And you get overwhelmed with all these formulas. So what we could do, we could go through and, you know, circle the ones, these are the only ones that we're using or that we've used so far. And that'll give you something, you know, of course, hopefully you're going to remember this one, but something on a test if a formula sheet. All right, so I think that part of this shortcuts are pretty easy, meaning once you get that power rule down, bring the power down, subtract 1. Of course, the e to the x is easy. This is where it's just more steps. It's not more difficult, but more steps. Again, I think you will find every teacher teaches the way they were taught. I don't know why I never liked this whole UV stuff. What this is saying is that I have two functions. I have an f of x, and I have a g of x. Can somebody close the door, please, since they're having a party and we weren't invited? Thank you. And so that's all I'm saying is that u is f of x and this is g of x, because this makes it a little bit easier to understand. So this is saying leave my function alone, take the derivative of my second one, plus leave my second function alone and take the derivative of the first one. Now, if you notice, this being adding, it really doesn't matter which one you do first. It is going to matter when we get to the quotient rule, but on this one it doesn't matter. If you like leaving the second one alone and taking the derivative of the first one, plus leaving the first one alone, derivative of the second one, that's fine. Okay, but this to me makes it a little bit easier to see. That's what this is saying. Just means the same thing. All right, so if I have something like y equals 3 minus x squared times x cubed minus x plus 1. Now, in the past, I have had students that they just don't like the product rule. I don't know why. You guys have your own weird quirks, right? So there would be nothing wrong with just multiplying and distributing this out. And then you just have pure power rules. There's nothing wrong with that. I don't know. I think it's more work, okay, to do that. But especially if there's, you know, more terms here. But you could multiply these out and then do the power rule of every one. You'll get the same answer. Well, let's not do that. Let's kind of use our formula that says leave the first one alone. So that becomes 3 minus x squared. Take the derivative of the second one, which is what?
3x squared minus 1.
Very good. And you hopefully by, say, the end of, are we at war? Hopefully by the end of next week, let's not say this week, you're as fast as Sarah just answered. Okay, that's where you need to get with these to be able to go through them quickly. So that's this piece. I'm going to leave the second one alone. And what's the derivative of the first piece? What is it? Negative 2x. Okay, because once again, I'm looking at this. The derivative of 3 is 0. Then I bring the 2 down, so I have negative x, 2 minus 1, and 2x. So now we go through, and unfortunately, you know, this isn't something my math lab likes, and if I ever give you a multiple choice test, which I doubt I would, you'd have to work this all the way out anyway. So meaning I'm just going to do the algebra. I'm going to do 9x squared. So I'm just multiplying this out. It is still early, so watch my math. Minus 3 minus 3x to the 4th, and then plus x squared. And then now I'm going to multiply this out. So minus 2x to the 4th. I guess I'll leave it like this with a negative sign. So then plus 2x squared and then minus 2x. So that's all I did is multiply all that out. Now, of course, I'm going to go through here and see, okay, there's a 4th power. There's a 4th power. So negative 5x to the 4th. There's a squared when there's another one, so plus 12x squared, and then I have that, and that's very patriotic, and that's my final answer. Okay, so this would be something like, let's say this is the football problem. Well, hopefully you're thinking logically, well, how can she give that as a football problem? Where am I going to find that at a football game? What I would do is I would say, find this derivative, and maybe I would write it in a way that says at that. So what that means is you find the derivative, and then you just plug in the value, and then you'll get a numeric answer, okay? So that's what your football one's going to be like. All right, let's look at this. If I have something like find this derivative. Now, once again, this is a little difficult to teach those of you that have had this already. There is something that's called the chain rule. You don't know it yet. Some of you do. But we don't know the chain rule in section 3.3. So all we know that we could do with this is make it a product. And if I multiply e to the x times e to the x, remember you add the exponent, so that would be 2x. So that means the same thing. Now, with me saying that, for those of you that have had this before and you know the chain rule, you can use it anytime you want. Okay, we're to the point now with shortcuts. We get to the L'Hopital's rule, anything, those of you that recognize these words that I'm saying. Now it's a pretty much free-for-all after Monday's test. Okay, so use what you know. Well, here, I'm going to use this whole thing again, where this is my f of x, this is my g of x. I'm going to leave my f of x alone. What's the derivative of e to the x? I'm going to leave this e to the x alone. What's the derivative of e to the x? Kind of a stupid one, huh? So in other words, I get this. Now, again, kind of looking ahead, and I don't want to confuse you, but what the chain rule does is says, well, e to the anything, the derivative, is e to the anything, and then I take the derivative of what's on top, and that's where the 2 came from. Okay, but for right now, if you haven't had calculus, don't let that confuse you. You just might have to separate these into a product, which is what we did. But again, this is for future, a much easier way to do this with something called the chain rule. Last one is the quotient rule. And again, it's kind of like the product rule. It's not difficult. It's just this one's very time consuming. So if I have a quotient, I want to find dy dt of t squared minus 1 over t cubed plus 1. Now, once again, you could write this as this is f of x, this is g of x. So what I'm doing, I'm leaving the denominator alone times the derivative of the numerator minus leaving the numerator alone times the derivative of the denominator, and then all over the denominator squared. This one definitely matters because you're subtracting up top, okay? So leave the bottom alone times the derivative of the top minus leave the top alone times the derivative of the bottom, and then square the bottom. So away we go. All right, so I'm leaving t cubed plus 1 alone. I'm finding the derivative of t squared minus 1, which is 2t. And so that's that piece. Now, minus, I'm leaving the t squared minus 1 alone times the derivative of the bottom. 3t squared, there you go, 3t squared. All over, now I'm just squaring the bottom, which is t cubed plus 1 squared. Just like we did with limits, don't mess with the bottom until it looks like you might have to. This is one you don't got to do anything with it. This is how you're going to leave your answer. You're going to make the top look a little bit better, meaning I'm just going to multiply all this stuff out. So I'm going to have, what, 2t to the 4th plus 2t minus 3t to the fourth minus 3t squared all over t cubed plus 1 squared. So all I did was just multiply, distribute all that stuff out. Okay, again, I'm hoping I'm convincing you that this class is algebra. It's more algebra in this class than anything else. And so now I collect like terms. Don't forget to distribute that negative sign. So I have a minus t to the fourth plus 3t squared plus 2t all over that square. All right, now I shouldn't tell you this, but I'm going to be nice because you guys are my favorite. I'm sorry this is recorded. Y'all are not my favorite class. So let's say Cindy would put a god-awful quotient problem for your football game, and I did. And I said, okay, find this. So in other words, let's call this, I don't know, V, and find V prime of 1, which means you have to find the derivative and you have to plug in 1. Who says you got to go through all this crap? Couldn't I have plugged in 1 right there? Yeah, so be smart about that. Those of you that cannot go to the football game, I will be nice to you. If you cannot make the football game, go ahead and work it, bring it, and I might give you something out of pity. If the Cowboys win. And for some